Today, we are going to unpack the Internet of Things, or IoT. We're going to go on a journey, starting with the tiniest invisible signals that connect our world, all the way up to the massive systems that are beginning to run it. So let's just dive right in. So let me ask you a question. What could your smartwatch and an entire smart city possibly have in common? I mean, it sounds a little strange, right? One of them is on your wrist, counting your steps. The other is this huge, sprawling network managing traffic and energy. But they are absolutely connected. So what's the deal? Well, it all comes down to communication. Both your watch and that city, they rely on a whole set of invisible languages. We call them wireless protocols that let them talk to each other and to the internet. This is the real fabric of the IoT. Just like us, devices need a common language to get anything done. But in the world of IoT, it's not like there's just one universal language. Nope, there's a whole family of them. And each one is highly specialized for a different kind of conversation. Think of it like a constant balancing act. Some jobs need a device to shout over really long distances, but maybe it doesn't need to say very much. Others need a device to whisper really complex information super fast, but only across a room. Every single IoT language is a unique solution to this puzzle of balancing range, data speed, and, crucially, power. So here are some of the big names in the game. You definitely know Bluetooth, right? It's essential for all our personal gadgets. But there are also these specialized languages, like Wi-Fi Halo, which basically gives Wi-Fi longer legs for things like outdoor cameras. And then there's LoRaWAN, which is designed for tiny, tiny devices that have to send signals over huge distances. Each one is a tool for a very specific job. And this is where it gets really interesting, because you can see those trade-offs in action. Just look at Wi-Fi Halo and LoRaWAN. Halo is fantastic for sending bigger chunks of data, think video from a security camera, over a much longer range than your home Wi-Fi. But LoRaWAN is the marathon runner. It sends these tiny little packets of data over several kilometers using almost no power. Perfect for, say, a sensor in a farmer's field that needs its battery to last for years. Okay, so we've got the languages down, but who or what is actually doing all this talking? Let's peel back the layers and take a look at the anatomy of a smart device itself. Turns out, pretty much every smart thing is built on a stack of 4 basic layers. It starts with the physical hardware right at the bottom, and then it builds all the way up to the application at the top, the part that actually does the useful thing we want it to do. So at the very foundation, you've got the hardware. This is the actual physical body of the device. It's the collection of chips and sensors and radios that lets it feel and interact with the physical world around it. Without this layer, literally nothing else can happen. And if you break it down, it's actually pretty intuitive. You've got the processor, that's the brain. You've got storage, which is its memory. The sensors are its senses, letting it detect temperature, motion, light, you name it. And finally, the radio, that's its voice, letting it speak those wireless languages we were just talking about. Okay, next up is firmware. Now, if the hardware is the body, think of firmware as the brainstem. It's that deep primal code that wakes up the hardware and gets it ready for action, way before the main operating system even loads. It really is the first spark of life for any device. Sitting right on top of the firmware is the operating system, or OS. A lot of these IoT devices actually run a super lightweight version of Linux. The OS is like the conductor of an orchestra. It manages the brain, the memory, the communications, making sure all the different applications can run smoothly without tripping over each other. So, we have devices that can sense, think, and talk. What happens when you multiply that by billions and then connect them all together? Well, that's when you start to change the world. Let's take a look. It all starts with us, with our own bodies. Wearables like smartwatches and fitness trackers are creating something called a wireless body area network. They're constantly monitoring our health, giving us insights and alerts that, not too long ago, you could only get in a hospital. We are literally becoming connected objects ourselves. Then you go to work, and IoT becomes this incredible engine for efficiency. Smart sensors can automatically adjust the lights and the heat based on who's in the room, which saves a ton of energy. They can also analyze how spaces are actually being used, helping companies design offices that are way more effective. And then you scale it all the way up to an entire city, and that's where IoT starts to feel like science fiction. It can optimize traffic flow to reduce congestion, monitor air and water quality in real time, and give emergency services critical data to help keep us all safe. Now, as you can imagine, building these huge systems isn't easy. You can't just connect a billion devices and cross your fingers, hoping they'll work together. That would be absolute chaos. You need a blueprint. You need an architectural model to manage all that complexity. And that is exactly where reference models come in. Think of it like a universal set of Lego instructions for the entire IoT world. It doesn't tell you exactly what to build, but it gives every single engineer a common set of rules and pieces to work with. This is what ensures that a sensor from one company can talk perfectly to a gateway from another, letting the whole system scale up reliably. Okay, now for the really crucial parts. Connecting every object in our world has incredible benefits, but it also opens up enormous new risks. And this brings us to what is maybe the single biggest challenge of the IoT era: security. So, in the security world, pretty much everything boils down to something called the CIA triad. Confidentiality, that just means keeping secret. Integrity means making sure the data can't be messed with. And availability means the system has to be up and running when you actually need it. If even one of these three fails, the entire system is compromised. And believe me, the threats are very, very real. We're talking about attackers who can clone devices, who can replace that fundamental firmware with malicious code, or even launch attacks that just shut down essential services entirely. Every single connected device is a potential new doorway for an attacker. You know, there's a great quote from Bill Gates that just perfectly captures the double-edged sword of all this. Automation applied to an efficient operation will magnify the efficiency. But the unspoken second half of that rule is that automation applied to an insecure operation will magnify the risk. So what's the big takeaway here? The Internet of Things isn't just one thing. It's this incredibly complex ecosystem, built up layer by layer, from hardware and firmware through operating systems and apps, all speaking these different wireless languages. And making sure that this entire stack is secure, well, that's the great engineering challenge of our time. And that leaves us with one final critical question. The benefits of this connected world are obvious, but as we race to build it, we have to stop and ask ourselves, are we building a world that's just smart, or one that's smart and resilient? Are we really prepared for this?